I am Dr. Jisha Mishra. Welcome to today's lesson on TTL, RTL and DTL. In the previous lecture, we have seen basics of logic families. In this lesson, we will explore the some basics of TTL, RTL and DTL and also the example of logic gates. Now we discuss what is TTL means. TTL stands for transistor logic and its working. Logic gates like NAND, NOR are used in a daily applications for performing logic operations. The gates are manufactured using semiconductor device with BJT, diode, RFETs. Different gates are constructed using integrated circuits. Digital logic circuits are manufactured depending on specific circuit technology or logic families. The different logic families are RTL. RTL stands for register transistor logic. DTL. DTL stands for diode transistor logic, and TTL. TTL already say transistor logic. ECL is emitter coupled logic. R CMOS complementary metal oxide semiconductor logic. Out of this, RTL or DTL are rarely used. This article discusses on overview of a transistor logic or TTL. Transistor logic history. The TTL or transistor logic. Logics are invented in the year of 1961 by James L. Blue of TRW. It is suitable for developing new integrated circuits. This actual name of TTL is TCTL, which means transistor coupled transistor logic. In 1963, a manufacturing first commercial TTL devices were designed by Selvina known as SUHL or Savellania University High Level Logic Family. After the Texas Instruments Engineering launched the 5400 series ICs in the year of 1964 with the range of military temperatures. Then the transistor logic became very popular. After that, the 7400 series was launched through the narrow range in the year of 1966. The compatible parts of the 7400 families launched by Texas Instruments were designed by several companies like National Semiconductor, AMD, Motorola, Intel, Fairchild, Signetic, Intersil, Mullard, SGS Thomson, Siemens, Rifa, etc. The one and only one manufacturing company like IBM was launched non-compatible circuit using TTL for their own use. The transistor logic was applied to the many bipolar logic generations by slowly improving the speed as well as power utilization over about 2 decades. Usually, each TTL chip includes hundreds of transistors, generally functions in a single package range from logic gates to a microprocessor. The first PC like Canback 1 was used transistor logic for its CPU as an alternate of microprocessor. In the year 1970, the data point 2200 was used TTL components, and it was the base for the 8008R. After that, the 86 instrument sets. What is the transistor logic? The transistor logic TTL is a logic family made up of BJT, bipolar junction transistor. As the name suggested, the transistor perform two functions like logic as well as employing the best example of TTL are logic gates, namely the 7402 NOR gates are the 7400 NAND gates. The designing of TTL logic gates can be done with register and BJTs. There are several variants of TTL which are developed for different purpose, such as radiation 100 TTL package for space applications and low power Schottky diode that can provide an excellent combination of speed and lesser power consumption. Type of transistor logic TTL. TTLs are available in different types and their classification is done based on the output like the following: standard TTL, fast TTL, Schottky TTL, high power TTL, low power TTL, advanced Schottky TTL. The fast TTL is used to increase the transition for low to high. These families attend PDPs of 4 petajoules or 10 petajoules correspondingly. LVTTL or low voltage TTL for 3.3 volt power supplies as well as memory interfacing. Schottky TTL was launched in the year 1969 and it is used to avoid the storage of change to enhance the switching time by using Schottky diode clamps at the gate terminal. This gate terminal operates in 3 nanosecond. However, it includes high power dissipation like 19 milliwatt. Low power TTL operates with a 33 nanosecond switching speed to reduce the power consumption like 1 milliwatt. At present, this was replaced through CMOS logic. High speed TTL has faster switching as compared with normal TTL like 6 nanosecond. However, it has high power dissipation like 12 milliwatt. Low power TTL uses high resistance values. For low power TTL, the Schottky diode will provide a good blend of speed as well as decreased power utilization like 2 milliwatt. This is the most general type of TTL used like glue logic within microcomputers, basically replace the past subfamilies like L, H and S. Now we discuss the characteristics of TTL. First was is fan out. The number of loads the output of a gate can be derived without affecting its usual performance. By load we mean the amount of current required by the input of another gate connected to the output of the given gate. Power dissipation. It represents the amount of power needed by the device it is measured in milliwatt. It is usually the product of supply voltage and the amount of average current drawn when the output is high or low. Propagation delay, it represents the transition time that elapses when the input level change. The delay which occur for the output to make the transition is the propagation delay. Noise margin, it is represents the amount of noise voltage allowed at the input which does not affect the standard output. Classification of transistor logic, it is a logic family consisting completely of transistor. It employs a transistor with multiple emitter. Commercially, it starts with the 74 series like the 7404, 74S86 etc. It was built in 1961 by James L. Bowie and commercially used in a logic design in 1963. TTLs are classified based on the output. Open collector output. The figure 1 shows the open collector output. The main feature is that its output is 0 when low and floating when high. Usually an external VCC may be applied. In the figure 1, transistor Q1 behaves as a cluster of diode placed back to back with any of the input at logic low. The corresponding emitter base junction is forward biased and the voltage drop across the base of Q1 is around 0.9 volt, not enough for transistor Qt and Q3 conduct. Thus, the output is either floating or VCC is high level. Similarly, when all inputs are high, all base emitter junction of Q1 are reverse biased and transistor Q2 and Q3 get enough base current and are in the saturation mode. The output is at logic low. For transistor to go saturation, collector current should be greater than beta times the base current. Now we discuss about the application of open collector output include the following. The first one is in driving lamps or relays, in performing wired logic, in the construction of a common bus system. Now we discuss about the totem pole output. In the figure 2, we see the totem pole figure. Totem pole means the addition of an active pulse up the circuit in the output of the gate, which results in a reduction of propagation delay. The figure 2 shows the totem pole outputs. Logic operation is the sum as the open collector output. The use of the transistor Q4 and the diode is it to provide quick changing and discharging of parasitic capacitance across Q3. The resistor is used keep the output circuit to a safe values. Now we discuss about the 3-state gates. Figure 3 shows the 3-state gates. and it is provide three state output like the following: low level state when a lower transistor is on and an upper transistor is off, high level state when the lower transistor is off and the upper transistor is on, third state when both transistors are off. TTL family features: it allows a direct wire connection of many output. The feature of the TTL family includes the following: logic low level at 0 to 0.2 volt, logic high level is at 5 volt, typical fan out of 10. It means it can support most 10 gates at its output. The feature of TTL family includes the following: a basic TTL device drawn a power of almost 10 milliwatt, which reduce with the use of Schottky device. The average propagation delay is about 9 nanosecond. The noise margin is above 0.4 volt. Series of TTL ICs. TTL ICs mostly start with the 7 series. It has 6 subfamilies given as low power device with a propagation delay of 35 nanosecond and power dissipation of 1 milliwatt, low power Schottky device with a delay of 9 nanosecond, advanced Schottky device with a delay of 1.5 nanosecond, advanced low power Schottky device with a delay of 4 nanosecond and power dissipation of 1 milliwatt. TTL device nomenclature: the first two names indicates the name of the subfamily the device belongs to. The first two digits indicates the temperature range of operation. The next two alphabets indicates the subfamily the device belongs to. The last two digits indicates the logic function performed by the chip. The example are 74LS02-2 neither input nor gates, 74LS10 triple 3 input NAND gates. Difficult TTL circuit. Logic gates are used in daily life in applications like clothes dryer, computers, printer, doorbell, etc. The three basic logic gates implemented using TTL logic are given below. Typical TTL circuit: NOR gates. Suppose input A is a logic high, the corresponding transistor emitter base junction is reverse biased and base collector junction is forward biased. Transistor Q3 get base current from supply voltage VCC and goes to the saturation. As a result of the low collector voltage from Q3 transistor, Q5 goes to cut off, and on the other hand, if another input low, Q4 is cut off and the corresponding Q5 is cut off, and output is connected directly to the ground through transistor Q3. Similarly, when both input are logic low, the output will be logic high. Figure 5 shows the TTL circuits on NOT gate. When the input is low, the corresponding base emitter junction is forward biased and the base collector junction is reverse biased. As the transistor Q2 is cut off and also transistor Q4 is cut off, transistor Q3 goes to saturation and diode G2 start conducting and output is connected to VCC and goes to logic high. Similarly, when input is a logic high, the output is at logic low. TTL comparison with other logic family. Generally, TTL device uses more power and compared to the CMOS device, but power utilization does not enhance through clock speed for CMOS device as compared to current ECL circuits. Transistor logic uses low power but has simple design rules, but it is significantly slower. Specification is basic gate, TTL NAND gate, CMOS NAND or NOR gate, and ECL has OR gate. Now the specification is components, positive elements and transistor in TTL, CMOS MOSFETs, and ECL is a positive and transistor. Now fan out, the fan out TTL is 10 and the fan out CMOS is greater than 50 and the fan out ECL is 25. The characteristic is noise immunities. The noise immunity is strong for TTL, slow, extra strong for CMOS and good for ECL. Now the noise margin is moderate for TTL and high for CMOS and low for ECL. TPO in nanosecond is 1.5 to 30 for TTL, 1 to 210 for CMOS and 1 to 4 for ECL. And circuit roll in megahertz is 35, 10 and more than 60. Figure of merits is 100, 0.7 and 40 to 50. Advantage and disadvantage. TTL is mainly immune to harm from stationary electronic discharge, not like CMOS as compared to CMOS. These are economical. The main drawback of TTL is high current utilization. The TTL high current demands can lead to obsessive function because output state will be turned off when the different TTL version that have low current consumption will competitive to CMOS. The main benefit of TTL it is we can easily interface with other circuits. Our ability to generate different logic function because of creation voltage level as well as good noise margin. TTL has good feature like fan in, which means the number of input signals that can be accepted through an input. TTL applications. The application of TTL include the following: used in controller applications for providing 0 to 50 volts, 50 watt used as a switching device in driving lamps and relay used to processor of mini computers like DC VX used in printers and video display terminals. Registered transistor logic. Now we discuss about RTL, registered transistor logic. The registered transistor logic RTL circuit is one of basic logic circuits in digital logic family. It is bipolar saturated device. The RTL logic is popular because of its simplicity. The RTL circuit consists of resistors as input and transistor as the output side. Two input RTL NOR gate transistor are used as the switching device. The meter of the transistor is connected to the ground. The collector terminals are tied together and given to the supply through the resistor RC. The collector resistor is known as a passive pull-up resistor. The following figure show the circuit diagram of two input RTL NOR gate. Q1 and Q2 are the two resistors. A and B are the two input gives the base of two transistor and Y is the output. Circuit diagram of two input RTL NOR gates. Figure shows the two input RTL NOR gates when both the input A and B are at 0 volt and the logic 0. It is not enough to turn on the gates of both the transistor, so the transistor will not conduct. Due to this, voltage VCC will appear at the output Y. Hence, the output is logic 1 or logic high at terminal Y when any one of the input either A or B is given high voltage or logic 1. Then in the figure shows the truth table of two input RTL NOR gate. Transistor with high gate input will be turned on. This will make path for the supply voltage to go to the ground supply voltage to go to the ground through the resistor RC and the resistor. Thus, there will be 0 volt and the output terminals Y. When both the input is high, it will derive both transistor is turned on. It will make a path for the supply voltage to flow to the ground through resistor RC and the transistor. Therefore, there will be 0 volt at the output terminal Y. The truth table shows the truth table of NOR gate. 3 input RTL NOR gate. The above discussed 2 input RTL NOR gates is the basis of the logic circuit. Bolt the resistor and transistor. The 3 input resistor transistor logic NOR gate can also construct as shown below. The operation is similar to the 2 input RTL NOR gate. The limitation is when the transistor is switched on, the power dissipation increase as the current flow through the base and the collector. Also, the RTL gate has poor noise margin, poor fan out and the propagation delay is more. This figure shows the 3 input RTL NOR gate circuit diagram. The diode transistor logic DTL is belong on the digital logic family. In the figure, logic circuit has the diode is the input side and the transistor at the output side, and so the name is named diode transistor logic. it has more advantage than RTL register transistor logic. Logic circuit of 2 input NAND DTL 2 input DTL NAND gate. The above figure shown the circuit for 2 input DTL NAND gate. It consists of 2 diodes and the transistor. The 2 diode DADB and the resistor R1 from the input side of the logic circuit. The common emitter configuration of transistor Q1 and resistor R2 from the output side. When both input A and B are low, the diodes D and the DADB become forward biased, and so both diode will be conduct in the forward direction. So the current due to the supply voltage VCC is 5 volt will go the ground through R1 and the 2 diode DA and DB. The supply voltage get dropped in the resistor R1 and it will not be sufficient to turn on the resistor. So the resistor will be the cut off mode. Thank you.